Hello class. Alright, so this video is about binomial probabilities. And first of all, there are three things that need to be true in order for data to be binomial. The first is that you have to have options, only two. You have to have a binary data set, which means to say that you can either have a success or you can have a failure. For instance, when I flip a coin, the coin either comes up heads or it comes up tails. There's only two options. Either you voted or you did not vote. Either the answer is yes or the answer is no. There can be no maybe. Secondly, they need to have the same probability for each trial. So each time you're doing the same thing over and over again, each time you're flipping that coin in the same way, so that the probability remains the same for every trial. And last, there needs to be a fixed number of trials. We're not talking about infinite number of trials where it's not a fixed number or not knowing the number of trials. It has to be a fixed number. When you're doing these, you want to make sure that your sample size is large enough that you're going to get accurate data. So if I'm pulling from 100 people and I decide to sample 10, that would be 10% of the data. You need to make sure that the amount that you're sampling is 10% or less than the total population to make sure that you are going to get accurate data. All right, so some general variables we're going to use in our formulas. We're going to let the number of trials be n. Okay, and so let's say you flip a coin 10 times, then 10 is the number of trials. Successes are going to be x, so maybe let's say success for me is getting heads. Maybe I got 4 heads out of 10, so my successes would be 4. The failures, well, if I had 4 successes, I must have had 6 failures. And how did I get that? That's the total number minus the successes. So n minus x will give me the number of failures. The probability of success is going to be p, which means that the probability of failure will be 1 minus p. The mean, which also tells us the expected value, is the number of trials times the probability of success for those trials. So in variables, that would be that mu equals n times p. The standard deviation is the square root of the number of trials times the probability of success times the probability of failure. So sigma equals the square root of n times p times p minus 1. And that brings us to the formula that is the main point, or one of the main things that we're going to be doing with the binomial data, and that is finding the probability of events. So in order to do that, the probability is going to equal the number of possible combinations of outcomes, such as if I'm flipping a coin 3 times, do I get heads heads? Do I get tails tails? The number of possible combinations of outcomes times the probability of success to the power of the number of times you were successful times the probability of failure to the power of the number of times that you failed. So with variables, that would be the probability is equal to, this is the formula for combinations. This explanation point is factorial, remember that. So we have the number of combinations times the probability of success to the power of x times the probability of failure to the power x n minus x. All right, let's look at an example using that. Probability, I'm going to select 3 people from the room, and I'm going to guess their numbers. What is the probability that I will correctly guess 2 out of 3 of your guys' numbers? All right, so that's the problem. Let's look at some of the variables. I'm going to pick 3 people, so that's 3 trials. I'm hoping to have 2 successes. The probability of success, if you guys are picking the numbers 1 through 5, that means the probability of success is 1 out of those 5s, or 0.2. And the probability of failure would be 4 out of 5, or 0.8. So I'm going to plug into the formula, and I have 3 factorial So I'm going to plug into the formula, and I have 3 factorial over 2 factorial 1 factorial. That's the number of different combinations that I can have. I could have correct, wrong, wrong. I could guess in lots of different orders, right? So this is going to be all the different orders in which I could choose 3 correctly. And then times the probability of success is 0.2 to the power of 2 because I have 2 successful trials. And the probability of failure is 0.8 to the power of 1 because if I have 2 successes, I must have 1 failure. So when I multiply that out, I have 3 times 0.04 times 0.8, which gives me a 9.6% chance of getting 2 of 3 of them right. So in other words, I have a very small percentage chance of actually guessing them correctly. And that is binomial probabilities.